by cylindrical shells. Let me first describe what a cylindrical shell is to you first. Okay, so cylindrical shell is a cylinder, but just the outside, thin layer outside of it. Well, shell. That's what a shell is, right? So where this thickness is infinitely thin. Okay, so let's say you have a certain thickness called delta x. Okay, certain thickness. I didn't draw it very nice there, so that's a better picture. Okay, so I'm saying this right here is this little thinness, right? This is delta x. So let's say you get this like a can, right? A layer of can. Let's say you cut it right here. If you cut it right there and you open it up, right? Let me do a partial open. It'll look like this, right? Okay, so it's gonna open up like that. Do you see that? Okay. And if you completely open it up, it's actually a rectangle, right? With a certain small thickness. Okay. Where the thickness is, right, the thickness here is delta x. What is this length from here to here? Okay, so this here is this length. So let me just highlight this right here is this. Okay, which is the circumference of the circle. Okay, so if this circle on the top had a radius of r, this would be 2 pi r. And this length on the side here, this length here, okay, that's this, which is the height of the cylinder. So the volume is 2 pi r times h times by a delta x, right? Times by a delta x of this thin cylindrical shell. Okay, so let's see how we can use this to generate volume. Okay, so let's try this example. And you'll see why, in this example, why we need this method. Okay, so first of all, the axis. Now, because you can actually factor out the x like this, x squared actually, you get 2 minus, it's easy to graph this from polynomial. It recognizes a polynomial graph with a multiplicity root of 2, and it's 2 minus x, so it's gonna have a root at 0 and at 2. Okay, and it's a cubic graph, so and it leads with a minus x cubed, so it's gonna start from the top. Okay, and it's gonna look like this, like it starts from the top, bounce off, and it's gonna go back down like this. Okay, so it's this graph, and bounded by and also y is equal to 0, which is the x-axis. So we're talking about this area right here. You're going to rotate that about the y-axis. And when you do that, we're going to get a shape that looks like this, right? So it's going to spin like this, right? And at the bottom, it's a full circle too. It's like a mountain with a lake in the middle. I don't know, can you visualize that?
No question.
Oh, shoot. I shouldn't have drawn it in there. Okay. Now it's not, we're done. We just have to evaluate it, right? It's gonna be x to the power of 4 half 1 over 5 x to the power of 5. Is that right?
Can I go to the washroom? I think I shifted my contacts and it hurts.
Yes. Okay. See you on your phone line?
Yeah.
Okay.